Hello everyone, so my name is Dilini. I'm going to perform real-time ETL using the concept of polling in today's tutorial. So before we start implementing the ETL, I would like to explain the advantages of having a real-time ETL. So that's the customers of the application are benefited with the latest data as and when it is available in the source system, because if we run the ETL in real time, we can provide fresh data for the customers instead of just executing the ETL on a daily basis. So there are various ways to perform real-time ETL. For example, we can use polling, or we can use subscription, and also we can use capturing data changes, that is by monitoring the database logs and triggers. So in this tutorial, I'm going to use the concept of polling. So let me just explain the scenario first. So I have a MySQL table here, and this is what the ETL is going to poll. So let's assume in this in our source system, the data is loaded by component by component. So let's say when we start loading data for the first component, an automated process will update this row saying that the status of the component 1 is started, and it has a timestamp column in which we are going to record the time the component 1 was completed loading its data. So once the source system finishes loading data for component 1, an automated process will enter the timestamp that was completed. So that is basically the tracking table I am going to use for this polling. So let's assume this system has two components. For this tutorial, I am going to have two components here, and at the beginning it will have two rows with the timestamp being set to null. So that's the design for the tracking table I am going to use, and to design this ETL I am going to use Talend, which is an open source platform for data integration. So you can see, you can download the community edition from their site. I'm using this big data integration product, so you can download it here and use to implement this ETL. So before implementing, I would like to explain the design here. As a best practice, if we are going to use dynamic parameters or environment variables in our ETL, then it is better to import those parameters from an external file. So that is what I have indicated here using this load context box. So the first and the foremost thing we have to do when we implement an ETL is to load that context from an external file. Then so this is just one way of designing polling using Talend. So here I have used 3 jobs, that is one main job, and within it I have 2 other jobs, one child job as well as another job to load components of the corresponding component based on its status. So the main job acts as the job that will trigger the polling, and inside the main job we have one child job. This will continue to poll the tracking table periodically. So that is basically the design I am going to implement using Talend. So let me just I'm going to start by creating a new Talend project. Here you can create new project and you have to provide a project name, and I'm going to create it. So now the project was created here. You can open the project. So now we have a new project. All the job designs we are going to do will be listed under this job designs title. So I am going to create a new folder here for polling. And then inside this folder I am going to create the 3 jobs I am going to use. So the first one will be polling main job. And the next one will be polling child job. And the other one is component loading job. So I have created 3 jobs here. So let's start by designing the main job first. So first I am going to load the context to our ETL. Talend provides a special component called t-prejob. You can search components in this palette. So here, as you can see, it provides a t-prejob. This component ensures that it will get executed before any other components we have defined in this main job. So I am going to read those dynamic parameters from an external file. So I will need a t-file input delimited component as well. So this will load the file to the ETL. So to connect these 2 components, the prejob provides only one connection type that is on component OK. So I am going to use it. And here we have to configure this component to read the context file. So this is a sample context file. This is the context file I am going to use for this tutorial. So you will have to provide the file path. All the settings of these individual components are listed under the component tab. So here you will have to provide the path of the context file, and then the field separator is the equals sign, and then you have to provide the schema of the file. Here I am going to use a simple key value format. So that is the schema of the file. And another attribute is this die on error attribute. That is, if you want to kill the whole ETL process when this individual component fails due to some error, you can tick this attribute so that the whole ETL will die if an error occurred in this component. So that is, now we have read the file to our ETL, and now we have to load the context using that file. So Talend provides another special component, the t-context load. Again, I am going to connect these 2 components here. As you can see, it provides various types of connections, but I am going to use the row main connection because I have to load each row in this file. So that's why I am using this connection. And you can see that the schema is synced automatically, and here as well. So if you check, you can see the schema was synced automatically. So now we have loaded the context to our ETL. Then what we are going to do is start implementing the polling implementation. So first I am going to use, query from the tracking table and get the number of incomplete components. So to do that, I will have to use a tMySQL input. This will execute the query we are providing, and it will provide the output as a list. So here again you should configure this component. So here you have to provide the connection information. And the query I'm going to use here is this one. That is, I'm going to select the count of IDs from the tracking table where the timestamp is null. It returns the number of incomplete components from the tracking table. So this component returns an integer value. So we have to edit the schema and provide that integer value as the output from this component. So now we have the number of incomplete components from the tracking table, and we have to process that value. So I am going to use tjava row. So Talend provides two Java components. One is tjava row and the other one is tjava. Both are very similar except for one difference. So if you want to process each row that is returned by its parent component, then you should use a tjava row component. So here I am going to process each row and just put the Java logic here in this component. So what I am going to do here is I created a context variable called continue polling, and I am going to set it to true as the default value. And if there are no incomplete if there are no incomplete components, then that means I am going to stop polling. So that is why I am checking here the total number that was returned by this MySQL query. So if it is equal to 0, that means I am going to stop polling. And also I have introduced another context variable called last checked, that is to get whatever the components that were completed within each cycle, the loop cycle. So I have introduced two context variables, so I should insert these context variables to the context of this main job. So you can do that by using this context tab. Here you have to insert those context variables. Okay, so now I have the loop conditions set, and another thing is I'm going to put these two parameters into a global map. That is because those parameters are going to be used by both this main job as well as the child job. That is why I'm going to put those parameters to a global map so that both jobs can access those parameters. So now we can start the loop. So Talend provides a T loop job. Here the connection type here I am using would be on subjob. Okay, that is whatever the components that are horizontally connected is known as one subjob. So here this is one subjob. So the T loop will be executed only after this subjob is completed. So here I am going to use a while loop, and you can provide the condition, loop condition here. So I am just going to check whether the continue polling parameter in my global map is true. That is the only condition I am going to check. So now what we are going to loop here is our child job. So here I am going to iterate the child job inside this loop. So now we have partially completed our main job. I am going to pause implementing the main job here and start designing the child job. So let's design the child job here. First, what we are going to do is we have to check the component status again inside the child job, because if the status was changed while we were transitioning from the main job to the child job, then we have to capture that change. That's why we have to first check if there was a status change, I'm using the same query here to get the count of incomplete components, and then I'm going to use the same logic here in this Java component as well. So that is, if I'm setting the continue polling to false, and if the total number of incomplete processes is greater than 0, I'm going to set it to true. So don't get confused by these context variables. If I am referring to a context variable inside a job, then its scope is limited to that job only. So that means this context.continue polling variable is accessible only within this job. And as you can remember, there was another continue polling variable inside the main job as well. So that variable is accessible only inside the main job. So here now I have changed the loop parameter, and then I have to check what were the components that were completed during this loop. So I am going to use another TMySQL input, because I am going to query again the tracking table. Now I am going to get the completed components from the tracking table. So this is the query I am going to use. I am selecting the description from the tracking table where the timestamp is greater than or equal to the context.lastCheckTime. That is why I use this last checked variable, because I can keep track of the time I last checked the tracking table. So this will return a string value, a description value. So I have to edit the schema and provide the output of this component. So the type is string. And then now we know the components that were completed during this iteration. So we have to process that output. So again we are using a tjava row to process each and every component that was completed during this iteration. So here the logic is, if there is at least one component, then I am going to load that component to the destination system. So I am using another context variable here, that is to decide whether I have to continue loading or not, and also I am using another context variable to keep to store the name of the finished component. So now I have 4 context parameters defined inside this child job. So I should insert them to the context of this child job. So I inserted those variables to the context of the job, and now I have a Boolean variable which decides whether I should load the component or not. So based on the value of that Boolean variable, I am going to load the component. So that is, to load that component, I am going to use this child job. I am not going to discuss how we can implement this component loading job, because all the extraction logics and the transformation and loading logics goes here in this job. So here I am going to run an if condition, and if the continue loading variable is set to true, then I am going to load that component. So here again I have to pass the component name for the child job, because that is required by the child job to load that component. So here you can transmit the whole context of the parent job to the child job, and if you have any specific parameters to be inserted, to be passed to the child job, then you can use this table here. So to pass parameters, the child job should have that parameter, so I have to define it in the context of the child job. So here I am going to use the component name parameter, and now as you can see here, I can assign a value for the component name of this child job using the value of the parent job. So the left hand side refers to the parameters in the child job, while you can provide whatever the values you want to assign in the right hand side. So then so now we change the loop parameters inside the child job. So we have to communicate that change to the main job. Passing parameters from main job to a child job is very easy, as I described here. You can pass whatever the parameters from the main job to the child job using this table, but passing the other way around, that is from the child job to the main job, is a bit tricky. We have to use some special components provided by Talend. So that is one component is the T fixed flow input. This generates a fixed flow using whatever the variables we assign to that component. So here I am going to provide the variables I want, that the variables the child job has to pass to the main job. So here I have two variables, continue polling, which is a Boolean one, and the other one is last checked. And the values will be context dot continue polling, and context dot last checked. Here again the left hand side refers to the parameters we have to pass for the main job, and the right hand side refers to the values. So we are referring to the context parameters within this child job. Now we have the fixed flow, and what we are going to do is we are going to put those parameters to an external buffer. So we use T buffer output component. This so here whatever the parameters we included in the T fixed flow input component will be sent to the external buffer. So here if you check the parameters were automatically synced for the output buffer. And finally we have to so if there is a possibility of not loading a component within a given iteration, so if a data loading does not happens in a given iteration, then I suggest we should stop or pause the ETL execution for a given time period. In that way we can achieve the periodic polling. So to do that, I'm going to check if we need to pause the ETL or not. And then I'm going to use the tsleep component here. So this sleep component should be executed only if the continue polling variable is true and there was no component was loaded in this iteration. So that is continue loading. Here I'm going to provide the time to sleep using my context file. So I have a parameter here for the sleep time in seconds, and I'm going to provide that parameter here. So this is again a context variable, so I have to add that to the context of this job, which is an integer value. So how am I going to tell the ETL that this value should be read from an external file is by providing the default value here as context.sleep time in seconds. In that way the ETL will read this value from the external file. So that's the child job. Now we have completed it. Let's design the rest of the main job. So now we have the parameters that were changed by the child job in an external buffer. So we have to update the parameters we inserted to the global map at the beginning of this main job with the changes that we did inside the child job. So to do that, I am going to again use the tjava component, because I have to iterate for each parameter. So here, if you check the child job, it doesn't show any parameters at first, but you can copy the child job schema and then you can see the parameters we inserted to the output buffer are shown here. So so now the main job can easily access those parameters. So here I am going to insert those parameters to the global map like this. Then to indicate the completion of polling, we can use another Java component, and here we can say that polling completed. So this component will be executed only after the while loop finishes its execution. So that is how we can design real-time ETL using the concept of polling. So let me run this, run the implementation I did here. To run this ETL, we can run the main job, and I suggest you should provide meaningful names for each of these components so that anyone can understand what you have done here. So now let's check the status of the tracking table. So here we have two components, and there are two incomplete components. So let's run the ETL. So here you can see that there are two incomplete components. So, and there are no components to load. So now I'm going to complete one component. Now you can see component 1 was finished. Let's wait for the next iteration, which will be executed within 15 seconds because the sleep time I provided was 15 seconds. So here you can see the current incomplete component count is 1 because I completed one component in the tracking table, and also you can, if you check here, you can see that data loading for component 1 started and data loading for component 1 ended. So let me complete the other component as well. Now you can see both components are completed. So our polling ended because there are no incomplete components, and you can see that data loading for component 2 started and data loading for component 2 was ended. So that is how we can implement real-time ETL using the concept of polling. And another thing is, as you can see, because we use that last checked variable, only the component that was completed during that during the iteration was loaded to our data to our destination system. So yes, that is how we can implement real-time ETL using the concept of polling. Thank you.